Why did Hurricane Milton intensify so rapidly? The combination of warm ocean waters, moist air, low wind shear, and a favorable path caused Hurricane Milton to increase its wind speeds by 145 kilometers per hour in just about 25 hours. Over 1 million people were ordered to evacuate from Florida as Milton approached the state's west coast, according to The Guardian on October 8th. Milton is now recognized as the third fastest intensifying hurricane ever recorded in the Atlantic, according to the U.S. National Weather Service. While much of the southern United States was still recovering from the impacts of Hurricane Helene, which hit in late September, the rapid intensification of Hurricane Milton caught many by surprise. In just about a day, Milton strengthened into a Category 5 hurricane, the highest level on the Saffir-Simpson scale, with winds reaching 290 kilometers per hour as it moved across the Gulf of Mexico toward central Florida. Milton underwent a process called rapid intensification, a term used for storms that see wind speeds increase by at least 55 kilometers per hour in 24 hours. Milton far exceeded this threshold, with winds surging by 145 kilometers per hour in just 25 hours, according to Climate Central, a research organization. This made Milton one of the most powerful storms ever to threaten the U.S. This storm is pushing the limits of what the Earth's atmosphere over this oceanic region can produce, said Noah Berggren, a meteorologist based in Florida. A hurricane forms due to a combination of various factors. In Milton's case, these variables combined into a nightmare scenario. The storm drew immense energy from the warm Gulf of Mexico waters, which were much hotter than normal. This energy translated into higher wind speeds. The Gulf had broken temperature records multiple times this year, with ocean waters resembling a hot bath in summer. Milton's core passed through areas of unusually warm water, 2 to 3 degrees Celsius above the seasonal average. Additionally, Milton absorbed moisture from the very humid atmosphere. Warmer air can hold about 7% more water vapor for every degree Celsius increase in temperature, making it easier for the storm to form and maintain its structure. The air around Milton was also highly unstable, allowing for stronger updrafts that fueled the storm. La Niña conditions played a role in reducing wind shear, the difference in wind speed and direction at various altitudes. With relatively even wind conditions, Milton was able to maintain a strong and well-organized structure. All of these factors combined to allow the storm to use the available energy more efficiently, explained Kim Wood, an atmospheric scientist at the University of Arizona. The perfect mix of warm water, moist air, and low wind shear was further enhanced by Milton's path across the western Gulf of Mexico, a region that had not experienced much hurricane activity earlier in the season. When hurricanes pass through warm waters, they absorb much of the heat, cooling the surface. However, the waters in the western Gulf had not been depleted by earlier storms, meaning Milton had an abundant supply of heat.